Okay, so in this class, we're going to review the definite integral and the first part of the fundamental theorem of calculus, and we're going to explore some contextual interpretations of the definite integral. So just a reminder, the expectation is that you'll work through all of the demo, which we do together, and then the group activities, which will sometimes mean having to finish those group activities outside of class time. The even more practice/challenge problem section is optional. It's there for folks who want additional practice or a good challenge, and for those speed demons who finish the group activities during class. All right, so I'm going to use some technology to evaluate a definite integral, the definite integral from 0 to pi of sine of t dt. I'm going to show you how to do it now, but if you have a graphing calculator, don't worry about it. I'm going to hand some out for the activities, and you can follow the instructions on how to do it then. For right now, you can just watch. So it says from the home screen, oops. From the home screen, we go into the math menu and choose FN int, that's for function integration. So we go math. Smartboard is not working well today. There we go. Math. Oh, what the heck? Math. Okay, choose function integration. And then it says to either make your screen look like this first thing, the integral from 0 to pi of sine of t dt, or fn int of sine of t, comma 0, comma pi. So that depends on which graphing calculator iteration you have, an older or a newer. So mine, I'm going to go 0 to pi, 0 to pi. Oh, this is going to get really annoying. Okay. 0 to pi. And then I'm going to enter my function, which is sine of t. So I'm going to use x because that's the button I have, sine of x dx. So instead of t's, I used x's. That's what your graphing calculator's default variable is. And then you just hit enter, and it says 2. So I used a calculator to evaluate the integral. Oh, I see what the problem is. Hang on. Okay, so my calculator said that the integral from 0 to pi of sine of t dt is 2. And what does that represent? So anybody remember from Calc 1? The area under the curve from x equals 0 to x equals pi, or t equals 0 to t equals pi. So this is my t-axis. So from 0 to pi, the integral measured the area under the curve. So that area is 2. So in general, the integral from a to b of f of t dt denotes the area under the curve over the interval a to b. So the symbol, this elongated s, a to b, and then there's whatever you put in these brackets is called the integrand. And then the dt tells you what variable you're integrating with respect to. That is called the definite integral. The numbers, the a and the b, are called the limits of integration, and the function that goes inside those brackets is called the integrand. If we have a continuous function f of t, for now we're going to assume it's completely above the x-axis. We're looking for an estimate of the area under the function from x equals a to x equals b. You can estimate that area using rectangles. And the more rectangles, the better the estimate. All right, so I'm going to calculate a definite integral here without having a formula. So I don't need a calculator. I want to integrate from 0 to 4 f prime of t dt as accurately as possible. And this is the graph of f prime. Okay. So the integral is the area under the curve. So I want to calculate the area under this curve, where area above the x-axis is positive and below the x-axis is negative. So we'll do this in 3 chunks here. 1, 2, and 3. Okay, 1 and 2 are going to be positive, 3 is negative. So area 1, so the integral from 0 to 4 of f prime of t dt, this is area 1 minus the area of 2 plus the area of 3. So we're going to find those 3 areas, add them together. So 1, that's a right triangle. And the base is 1, the height is 2, so its area is 1/2 base times height. 1/2 times 1 times 2 minus this triangle in area 2. Its base is 2, and its height is 1. 1/2 base times height. So 1/2, the base is 2, the height is 1. And then plus area 3, which is a right triangle. Its base is 1 and its height is 1. 1/2 base times height. 1 times 1. So this is 1 minus 1 plus 1/2. So that's 1/2 is the value of the integral. Okay, so a little detour. Theorem you should have seen before at the end of Calc 1 is the fundamental theorem of calculus. It says that if f prime is a continuous function on the interval to a to b, then the definite integral from a to b of f prime of t dt is just f of b minus f of a. So in English, it says that the definite integral of a rate of change is the total change. So referring back to the graph in question 4, they're telling me that f of 4 is 2, and I want to find f of 0. So the graph in question 4, I calculated an integral from 0 to 4. I know that the integral from 0 to 4 of f prime of t dt, according to the fundamental theorem, should be f of 4 minus f of 0. Right, the antiderivative, I dropped the prime. So I know this integral because I just calculated it. What was it? 1/2, yep. F of 4, they told me, was 2. And I would like to know what f of 0 is. So I used the fundamental theorem equation to solve for it. So I get f of 0 is 2 minus 1/2 is 1 1/2.